In this video, we're going to talk through finding the cross product of u and v without having to compute the angle between them. We know we could, using the dot product, figure out the angle between these two, and then use the formula u cross magnitude of u cross v is magnitude of u times magnitude of v times sine of theta. Theta being the angle between them. We could do that and work out the magnitude of this. We could you could use the right-hand rule and work out the direction of this. But that's, sort of a lot of work. How else can we do this? Well, one way is to use our algebraic properties of the cross product. So these guys, associative property, distributive, and the other distributive. So keep in mind these properties. Things distribute like they should. You just got to keep the order in mind. If we flip the order, we get negative of what we would have if we didn't. And we have the associative property. And then we have all these relations between I, j, and k are unit coordinate vectors. So what this means is we can take our two vectors here, u and v, that we want to compute the cross product of them, and we're going to first write them as sums of multiples of unit coordinate vectors. So do you remember how to do this? To break down a vector into I, j, and k's, and a sum or subtraction of these. This is 4 in the I direction, so that's 4i. Plus 3j, positive 3j, minus 2k. So that's how we can write u as a sum or difference of these unit coordinate vector scaled versions of these. And then we have v here, which is 2i minus j plus k. And so to do u cross v, what we're really doing then, u cross v, draw a line here, separate these, is 4i plus 3j minus 2k, cross product with 2i minus j plus k. And then we'll use the properties of cross product. So one property is the distributive law. I can distribute a vector over a sum. So what I'm talking about, what I'm going to do is I'm going to use which I can use either of these. They'll look a little bit different. I'm going to use this one. So I have a sum of 3 things here. Down below I have a sum of 3 vectors, and then I have a cross product. So that's okay. I'll just distribute the w to each of these. So what this is going to look like when I do this with 3 of them is I'm going to bring this vector here. I'm treating this like a whole vector, and it is, but I'm going to keep it in a parentheses, and I'm going to distribute this to each one of these terms. And I'm going to make sure to keep it on the right. So this will be 4i cross 2i minus j plus k plus 3j cross 2i minus j plus k, right? I'm distributing that 2i minus j plus k to each one of these, not plus, but rather minus 2k cross 2i minus j plus k. And really, I should be keeping these in parentheses like this, but we're just going to use that associative property of cross products to pull out these multiples. So let's take it down another notch. I have these separated, but now I can distribute this 4i across to each one of these in the other direction. And then using the associative property, I can just multiply the scalars that are scaling each of the vectors and bring them to the outside. So that is when I distribute this 4i across, here I'll get 8i cross I. So that's 8i cross I. Oops, I did I cross j. My bad. That should be I cross I. That's the first term. Minus 4i cross j plus 4i cross k. All right, so that's this first one taken care of. Let's move on to this middle one. So I'll have a plus 6j cross I. Remember to keep the orders intact. J cross I. I have a negative here, so minus 3j cross j. And then I have 3j coming through to the plus k, so that's 3j cross k. Plus 3j. Oops, I really don't need arrows. I've been sort of, I'll mention that now, sort of mixing notation with the ij and k. Usually ij and k, you don't really need arrows above them because we always use them for these unit coordinate vectors. They're assumed to be vectors, so you really don't need the arrows. J cross j, so where am I at? 3j cross k. Like that. And so that takes care of this middle term. Now let's handle this last one. I have a negative, I'm going to think of this like negative 2k across each of these. So this is going to be a minus 4k cross I. Remember to keep the order intact, k cross I. I have a negative and a negative, so this is going to be plus 2k cross j. Finally, negative 2k cross k. So minus 2k cross k. And this is pretty cool because now I have these each two I cross j, just cross products of unit coordinate vectors. And I know all these. One, I can work them out myself again if I just imagine R3 and I use the right hand rule. Or I can memorize this table or memorize this little mnemonic device. Either way, I can determine each one of these vectors now. So let's see. I cross I, well, that's 0. I cross j, that's k. I cross k, what's I cross k again? Point your fingers in the direction of I, curl them in the upward direction. That would be going along the negative y-axis. So this is negative j. J cross I, that's the opposite of I cross j, which we know is k, so this is going to be negative k. J cross j, those are parallel vectors, so that's 0. J cross k, j, that's positive I. I'm doing the right hand rule when I do each of these because I don't memorize it, I just use the right hand rule. K cross I, so upward, point your hand upward, go in the direction of I. K cross I is positive j. And then k cross j, that's minus I. And then k cross k, that's the 0 vector. So let's collect everything we have here. This was minus 4k. Here we have a minus 4j, because this was minus j. We have a minus 6k, a 0 here. We have a 3i. We have a minus 4j. And we have a minus 2j. Wait a second, did I screw this one up? It should be, remember this is how I recognized I messed this up. This should be perpendicular to both k and j. It means it has to go in either the positive I or negative I direction. So minus j here doesn't make any sense. This should instead be minus I. Right, k, j, that's a minus I. Good. So we did minus 4j here, and this is a minus 2i here. And then we had a 0 here. So collect all these. How many i's do we have? How many j's? How many k's? Let's look at our i's. 3i minus 2i, so that's just I. How many j's do we have? I have minus 4j and another minus 4j. That's my j's are right here. So that's minus 8j. And then let's see, my k's, I have a minus 4k and a minus 6k, so that's minus 10k. And so what is this vector? What is the cross product? It's 1, negative 8, negative 10. Wow, what a process to come up with our final answer of 1, negative 8, negative 10. All right, so a couple notes here. One, we don't want to have to do this every time. This was a lot of arithmetic and a lot of algebra. So we'd like to come up with a shorter way to do this. And two, what was the deal with the matrices? Remember, I started this section by talking about the determinant of matrices. So how does this have to deal with matrices? It turns out all these operations we did and all these cross products that we had to do between the unit coordinate vectors, you can encode all of this into a 3x3 matrix whose determinant is this vector. So this is the really sort of cool thing in this section is all of this algebra that we just did can just be done by computing a determinant of a matrix. So we'll see that in the next video. Can't wait to see you there.